Okay, so here in this video, we're going to look at the differences between mass and weight. The differences between mass and weight. So the first difference we're going to look at is the difference with your definition, right? Mass is the quantity of matter in a body. It is the quantity of matter in a body. For instance, if I have this circle, right? This is the mass of this circle. It's the quantity of matter inside this body. The quantity of matter, the quantity of matter in the circle is the mass of the circle, right? While weight is the earth pull of a body due to gravity. So weight is entirely a different thing from mass. This mass, let's say the mass is 5 kg, right? Is going to be pulled down. If I throw it up on the earth surface, it will come down, right? It will come down with a force. That force is due to the weight of the body. That force is the weight of the body. So weight is the earth pull of a body due to gravity. And the value for acceleration due to gravity on the earth's surface is 9.8 meters per second square, right? So mass is the quantity of matter in a body. Is the quantity of matter in a body. This is the mass of the circle. This is how big it is, right? It's the quantity of matter in a body. And weight is the earth pull of a body due to gravity. It is the earth pull. This body is being pulled down due to its weight, right? So weight is the earth pull of a body due to gravity. And the value for acceleration due to gravity on the earth's surface is 9.8 meters per second square, right? So another difference between mass and weight is that mass is constant. Mass is constant. So if this body, like this circle now, if it is 5 kg on the earth's surface, when you take it to the moon, it will still be what? 5 kg. Weight varies. What does that tell you? That weight differs, right? So a body that is weighing, let's say 6 Newton on the earth's surface may weigh 1 Newton in the moon, right? So weight varies. Your weight in Nigeria might be different from your weight in America due to the position of the earth, right? So one important difference between mass and weight is that mass is constant, weight varies, weight changes. Your weight in Nigeria, your weight on earth may be different from your weight in when you travel to space, right? So another difference between mass and weight is that mass is a scalar quantity, weight is a vector quantity. Mass is a scalar quantity, weight is a vector quantity. When we say mass is a scalar quantity, it means that it has magnitude but no direction. It's just the quantity of matter in a body. So this is just the mass of the circle, 5 kg. It has no direction. But weight is a vector quantity. What does that tell you? That if the weight of this circle is 5 Newton, it means that the weight is acting downwards. So it has direction, and the direction is towards the earth, towards the center of the earth, towards the ground, due to what? Gravity. So gravity is pulling the weight down. So mass is a scalar quantity, weight is what? A vector quantity. It is a vector quantity because it has direction, and the direction is indicated by this word, this arrow, right? So another difference between mass and weight is that the unit for mass is kg. So mass is measured in kilogram. In short, it is called kg, while weight is measured in Newton, and in short, it is what? N. Then another difference between mass and weight is that mass is measured with a beam, a chemical, or a lever balance. So you can use a beam balance to measure mass, you can use chemical balance to measure mass, you can use lever balance to measure mass, right? but weight is measured with a spring balance. Weight of a body is measured with a spring balance. So know the differences between these 5 major differences between mass and weight of a body, right? So let's look at this question. Which of the following is a measure of the amount of matter in an object? So we've looked at it before that mass is the quantity of matter in a body. So which of the following is a measure of the amount of matter in an object? It is what? Mass. So mass is a measure of the amount of matter in an object. That is just the simple definition of mass. So if I ask you what is mass, you should be able to tell me that mass is a measure of the amount of matter in an object, right? The next question is, which quantity depends on gravity? Is it mass? No. Is it weight? Yes. Weight depends on gravity. So like I said, weight is the earth pull of a body due to gravity. Anything you throw up comes down, right? The reason it is coming down is because of the weight of the body. The weight of the body that is being acted on by gravity. So gravity pulls it down. It pulls it down. So weight is the earth pull of a body due to gravity, right? That's a very simple definition of weight, and you should be able to tell me that anytime. So which quantity depends on gravity? It is what? Weight. So we've looked at the differences between mass and weight. Mass is the quantity of matter in a body. Weight is the earth pull of a body due to gravity. Mass is constant. Weight varies, right? So the mass of a body is constant. If it is 5 kg on the earth's surface, it is 5 kg, it will be 5 kg in the moon. But weight varies, right? If it is 5 kg, if it is 5, let's say if it is 10 Newton on the earth's surface, when it gets to the moon, it will reduce because there is no gravity there, right? So weight varies, mass is constant. So know these two differences. Then mass is a scalar quantity because it has magnitude. It can be measured, but it has no direction. Weight is a vector quantity because it has magnitude, which means that it can be measured and the direction is specified, right? It has a direction and the direction is towards the earth. So if I have a ball of 10 Newton, I throw it up, it will come down towards the earth. It has a direction, right? But mass does not have a direction. Then the unit for measuring mass is kilogram. In short, it is kg. The unit for measuring weight is Newton, and it is written as N, capital N in short. Then mass is measured with a beam balance, with a chemical balance, or with a lever balance. Weight is measured with a spring balance, right? So let's look at this other question that is here. What is the weight of a 10 kg object on the earth? Take acceleration due to gravity to be 9.8 meters per second square. So we have the mass to be what? 10 kg, and we have acceleration due to gravity to be what? 9.8. So the weight of the body is equal to the mass times acceleration due to gravity. So the weight is equal to, the mass is 10 times the acceleration due to gravity is 9.8. So 10 times 9.8 will be equal to 98 Newton. So the weight of the body is, or the weight of this object on the earth is what? 98 Newton. So the very important thing that you should know here is that is the formula for weight, which is weight is equal to mass times what? Acceleration due to gravity. So the correct answer is what? Option C. Very important. Then let's look at this question. Which of the following changes with altitude? So the altitude here simply means height, right? So the question is, which of the following changes with altitude? Which of them changes with height? So is it mass? Mass, like I said, is constant. It does not change with height. It does not change with anything, right? So it's not mass. Weight, yes. The answer is what? Weight. Weight changes with altitude. It changes with height, right? The weight of a body is more on the Earth's surface. When you get to the moon, the weight becomes less. That is why you find objects floating in space. The moon is a very large mass, right? The moon is a very large mass, but it is floating in space. Why? Because there is no gravity. There is no gravity. There is no force that is trying to pull it to the surface of the earth. The force of gravity is present only on the earth. Is present only in the earth, not on the earth. Is present only in the earth, right? And the value is what? 9.8 meters per second square, right? So which of the following changes with altitude? It is what? Weight. As the body goes up, the force of gravity starts what? Decreasing, right? Starts decreasing. Then let's look at the next question that we have here. If the gravity on the moon is 1/6 that of the earth, if the gravity of the moon, if the gravity on the moon is 1/6 that of the earth, what happens to an object weight on there? So A stays the same, B becomes 6 times more, C becomes 6 times less, then D becomes 9 times more. So what's the answer to this question? Let's read it again. If the gravity on the moon is 1/6 that of the earth, if the gravity on the moon is 1/6 that of the earth, what happens to an object's weight on there? So what that means is that if the gravity on the moon, so moon gravity, if moon gravity is equal to 1/6 of the gravity on the earth, of earth. So let's say the gravity on earth, what's the value for the gravity on earth? The gravity on earth is what? Is 9.8 meters per second square, right? So if the gravity of moon, or the moon's gravity, is equal to 1/6 of the gravity on earth, what will now happen to the object, the weight of the object on there? What will happen to the weight of the object in the moon or on the moon? So the moon's gravity, according to what is given to us in this question, will be equal to, of means times in mathematics, right? So that will be 1 times 9.8 divided by 6. 1 times 9.8 divided by 6. That will be equal to 1.63, right? So that will be 1.63 meters per second square. So this is the gravity on the moon, right? So what happens to an object's weight on there? So let's assume that since the mass of the object is not given to us, let's assume that the mass of the object is 100 kg, right? let's assume that the mass of the object is 1. You can assume it to be anything. You can assume it to be 20 kg. You can assume it to be 30 kg. You can assume it to be 1 kg. But I just want to assume it to be 100 kg for simplicity. So if the mass of the body is 100 kg, right, the weight on the earth will be equal to 100. Formula for weight is mass times acceleration, right? So the weight on the earth will be equal to the mass, which is 100 kg, times the acceleration due to gravity, which is what? 9.8. So 100 times 9.8, that will be equal to 980 Newton, right? So this is the weight on the earth. Then the weight on the moon will be equal to, like I said, the mass of a body is constant everywhere. It is constant. So the mass is still constant, 100 times the acceleration due to gravity on the moon. We've calculated it to be 1.63, right? 1.63. So 100 and 1.63, that will be equal to 163. So 163 Newton. So if you look at this weight, this is the weight on the moon and this is the weight on the earth. So the body is having more weight on the earth than what? In the moon. The body is having more weight on the earth than on the moon. So if the gravity on the moon is 1/6 that of the earth, what happens to the object weight on the, what happens to the weight of the object in the moon? So it becomes less, right? It becomes less. And the only place where we have less becomes less in this question is option C. So it becomes 6 times less. 6 times less. It becomes 6 times less. So is it really true? How? Okay, let's see. 980 Newton divided by 163 will give us what? 980 divided by 163 is equal to what? Is equal to 6.0, approximately 6, right? So the object will now become 6 times less. The weight of the object will become 6 times less on the moon. So the correct answer to this question is option C. So it's very important that you understand questions like this. This is a JAMB question. I can't really remember the year, but it's a JAMB question. I've seen it severally. So this is just the explanation to this. So with this, we come to the end of this lesson.